C is just a constant. Okay, it's going to ask us to use the definition to find f prime of x, right? This is what we've been doing so far. So I'm going to go and continue on. I have the limit as delta x approaches 0. And then constant just becomes c minus c all over delta x. C minus c is just 0 over delta x. Therefore, my limit is just 0. So this is when the constant rule comes to play. So the derivative of a constant function is always 0. That's it. So if I'm looking at example A, B, and C, right, if y is equal to 7, the derivative, in this case we're talking about dy over dx, is just equal to 0. Same exact thing as part B. F of x is equal to negative 3. Negative 3 is just a constant, so then f prime of x is just 0. Right? Part C, it says y is equal to k pi squared, where k is a constant. It is just a number. So then therefore, y prime is equal to 0. Okay, so that is just a rule of thumb, is whenever you have a function that is just a constant, it's just a number, the derivative is always 0. Okay? It's then asking us, and again, this is what we've been dealing with, is using the definition of derivative to find the derivative of each function. And you are going to go ahead and look for patterns. So I know some of us have already discovered this pattern, but let's go ahead and work through it. I want you guys to do what I went ahead. I'm not going to do a full video note of all the problems, so I just want you guys to go ahead and do them on your own. So I'm going to go and pick and choose which one I do. In this case, I'm going to do B and D. So like we've done this in the past, I'm going to go through the whole entire motions, right? So this becomes x plus delta x squared minus x squared all over delta x, and then I'm going to keep going. And you guys could do this as I'm doing this. Comes x squared plus 2x delta x plus delta x squared minus x squared all over delta x, right? My x squares cancel out. I can also cancel out delta x's, so then I'm just left with the limit as delta x is approaching 0. What is that? 2x plus delta x. Therefore, my limit is just 2x, right? Sorry, my derivative is just 2x, right? And if I'm looking at my original function, what happens is I take my power, I put it up front, and then I subtract it. So then this becomes 2x to the power of 2 minus 1, which is 2x to the first power, which is 2x. And that's the same exact thing as we got. So I know a lot of this is tedious work, but we are going to go ahead and talk about what is called the power rule. Okay, so same thing if I was doing part D, right? Again, if I were to go through the motions, right, I would get, we don't even have to do it. Let's just go ahead and call it from there. So I'm going to go and put the negative 1 out front. So if I rewrite it, f prime of x is equal to x to the negative 1, right? I'm going to go and put the power up front, subtract it by 1. So we get negative 1 times x to the power of negative 2, negative 1 over x squared. So this would be your new f prime of x. Okay, so this, and I want you guys to go ahead and actually do A and C, this is called the power rule. So if n is a rational number, then the function f of x is equal to x to the nth power is differentiable, and I can go ahead and say this. Again, what happens is I'm pulling the n, your exponent, out in front, and then I'm subtracting 1 from it. That's all it means. Okay, so if I was doing part A, I'm going to go ahead and multiply the exponent, subtract it by 1. So it becomes 5x to the 4th power. Right, same thing over here. I can go and rewrite it as x to the 1/3 power. I'm going to go and bring the 1/3 up front, subtract it by 1. So I get 1/3 x to the negative 2/3 power. And I will have to go and rewrite this one. There we go. It becomes 1/3 to the cubed root of x squared. Right? And then you guys can go and figure out part C. Okay, so we love the power rule. It's super handy, super easy peasy. I know you guys are like, what, Miss Welter? why didn't we start off with the power rule? Right, you guys had to go and work through the motions of finding the derivative using the definition of the derivative. Okay, so let's go ahead and start with example 3. So find the slope of a graph. So find the slope of the graph of f of x is equal to x to the 4th power. So we don't need to graph this. Let's just go ahead and take the function and go ahead and find f prime of x now using what we know, right? Again, I'm going to put the 4 over, subtract it by 1, so it becomes 4x cubed, right? This is your slope generator. Woohoo! Okay, so I'm going to go and find the slope of the graph using my new slope generator. So I can go and find the slope. And we know my slope generator is this guy. I'm plugging in, a negative 1 cubed. So my slope at x is equal to negative 1 is going to be negative 4. Right? Same exact thing. I can go ahead and calculate the slope. So the slope at x is equal to 0 is equal to 0. And same thing with the last one. The slope at x is equal to 1 is equal to positive 4. Okay. I went ahead and put example 4 as a highlighted one. We could go ahead and talk about it. So it says find an equation of the tangent line to the graph of f of x is equal to x squared when x is equal to negative 2. When we're talking about tangent line, we are going to write it in point slope form. So y minus y1 is equal to m x minus x1. Remember, you are taking the slope, right? The slope is the derivative. And then your y1, your x1, y1, that is just the point, right? So let's go and first find the derivative. F prime of x is equal to, I'm going to move the 2 up front, subtract by 1. This becomes 2x to the 1st power. Again, this is your slope generator. Right. Step 2, I can go and find f. Let's go and find the slope. Slope. Using my slope generator. It says when x is equal to negative 2, so that means my slope of the line is negative 4. Right? And then I can go ahead and write in my equation. So we don't know what y1 is. We have to go and find it. Right? I could just go ahead and plug in negative 2 into my OG function, right? So I'm going to go ahead and say f of negative 2 is equal to the negative 2 squared, which equals a positive 4, right? So my point is at negative 2 comma 4, right? So I get y minus 4 is equal to my slope, which is negative 4, times the quantity of x minus x1. Right, there I have a double negative, so I can keep going. Y minus 4 is equal to negative 4, x plus 2. And that is the equation of the tangent line. And we could just leave it like that. All right, let's go ahead and talk about what's called the constant multiple rule. So if f is differentiable, meaning if the process of finding a derivative is possible, right, and c is a real number, then c times f is also differentiable. So we are going to see that if we take the derivative of c times f of x, it becomes c times f prime of x. So here it's all that's really saying is just a constant. So a constant is multiplied by the derivative. Okay, so let's go ahead and do example 5. I'm going to do part A, B, and C with you guys, but I want you guys to try D and F. Okay, so let's go ahead and go through the motions. I'm going to go and find the derivative, right? So I'm going to go ahead, this is really to the power of 1. I'm going to bring it up front, subtract it by 1. So therefore, we get 3, right? It's really like 1 times 3, x's 0th power. X's 0th power is just 1, so 3 times 1, that gives me an answer of 3. So my derivative is just 3. Right? For part B, I might want to have to go ahead and rewrite it. This is really saying 2x to the negative 1 power. From here, I can go ahead and apply the power and constant rule. So it becomes -1 times 2x, negative second power, right? It becomes -2x, negative second power, -2 over x squared. Done. Right, part C, I can go and rewrite it. I could just rewrite it as 4 over 5t squared. Same exact thing. I'm going to bring the 2 up front, subtract it on out. So this becomes 2 times 4/5 t to the first power. Right, that becomes 8 over 5t. Or you could say 8t over 5. Either way works. Done. Cool. Now I want you guys to go ahead and try the other ones. Again, you might want to have to go ahead and rewrite them. So like for part D, I would rewrite it as 2 to the x of the 1/2 power. Part E, yeesh. Let's go and rewrite it. I have 1 over 2. This becomes x to the 2/3 power, and then I would even go 1/2 x to the negative 2/3 power. And then I would go ahead and apply the power rule. Okay, so go ahead and try the rest. All right, back with me. So more examples. Example 6, using parentheses when differentiating. Again, right, this is kind of what I did in example 5. It's just staying more organized. I can go and rewrite it. So if I'm starting with part A, I'm going to go and rewrite it as 5/2 x to the negative 3rd power. From there, I can go and differentiate. Bring that negative 3rd power up front, subtract it on out. I get -3 times the quantity of 5/2 x to the negative 4th power. So then this becomes -15/2. And the x to the 4th stays down below. Right? Part B, I do have to do a first step, right? It's 5 over the quantity, 2x cubed, so I have to go and distribute that cubed. So then this becomes 5 over 2 cubed is 8x cubed. This is really 5 over 8x to the negative 3rd power, right? Again, from there, I can go and differentiate. So this becomes -3 times 5 over 8 x to the negative 4th power. So then this one becomes -15 over 8x to the 4th. It's a really bad 8. Let me go ahead and fix that. Okay, so these two look very similar, but we got to make sure that we're applying the rules about our parentheses. Okay, same exact thing for part C and D. Go ahead and try it on your own. All right, back to it. Example 7. So it says power rule for a polynomial. So these are super easy peasy lemon squeezy, right? I just go ahead and apply the power rule as many times as needed. So like for part A, I'm going to go and apply the power rule to my first term. I'm also going to do it to my second term, and then you're going to see that, oh, 5, that is a constant. So what happens when I take the derivative of a constant, right? It just turns to 0. So as I'm applying this one, right, my first term becomes a 3x squared. My second term becomes a -4, because the 1 minus 1 gives me 0, right? So that's x, really x to the 0th power plus 0. Right, so then this becomes 3x squared minus 4, because I know that x to the 0th power is just 1, right? So it's -4 times 1. So this would be the derivative. Okay, I guess we could do part B. I would go and rewrite part B. We could do it over here. This is really -1/2 x to the 4th plus 3x cubed minus 2x. Same exact thing. I'm going to bring these guys to the front and subtract on out. Right, so let's see. So I get 4 times a -1/2 x to the cubed power plus 9x squared -2x to the 0th power. So then this becomes a -2x cubed plus 9x squared minus 2. And that is it. Okay.